Big day. We've got dirt being delivered. We've got some holes going in. Dingo. Working on the last hole. Had a big rock apparently that they were able to take care of. See, about 4.5 feet down or so. So after this, I guess they get these all lined up, get them set at the correct height, and pour concrete. And we have the columns all installed. Dingo did a pretty good job. It has a shorter flight, so rocks like that, which, you know, like this, they kind of get caught in it. So we had to do a little bit of hand digging just to pull that stuff out and clear it out of the way for the auger, but looks pretty good. All the purlins are in place, and now panels are being put in place. Also have the jacks here for adjusting the angle of the array on all of them down there. on my installation, I wanted a ground mount, and my contractor recommended this Sinclair Design Engineering ground mount. The nice thing about this is it has just center columns here, so I got a lot of room between here and my building over there, which is phenomenal. And it's adjustable, as you can see by the jacks here on each of the columns. And really a pretty straightforward installation. You can go on their website and see how these things are installed, and there's some videos, but essentially get your layout. He came in, contractor augered the holes. It's about 4.5, 5 feet deep, 2 foot in diameter. You want to get a layout with a string to set your distances. And that seemed like a pretty straightforward process as well. I knew I wanted to be a certain distance between the columns and my pole barn. And really, kind of like building a pole barn, you just need to get the columns on the line and plumb in location on the centers of where they need to be. Pour the concrete and pull them up to the correct elevation so that you've got a nice level setup regardless of the ground. And I knew when I installed these that I did have a different slope to my topography here. But we set the columns one day, and then really the installation goes fairly easily. Put the top girders on, mount the jacks, and then the purlins. You can see how they're oriented. So that's a Z purlin, up and over. So you want that portion right there to face to the north in this installation. They do provide a little bit of adjustment here. So if you're not exact, you can tweak it. You can see how the panels have slots for the installation of them as well, so they can be adjusted. Key is to get a nice and square array set up with all the purlins as they sit on the actual girder beams there. And if you didn't want to use the actual jacks, you can see there are holes up there that you can set this to a certain angle. So I'll show you the other side. You can see the punched holes in the girder. Pretty excited about this. And the Enphase inverters will mount up there as you go across. Something you'll note, double nut set up here, so you tighten it, back it off a little bit, and then put a double nut on it so that you have a little bit of looseness or play so that everything can move. And you can see that up there as well, because that's going to be a pivot point in the array as you make the adjustments. These are made, these ground mounts are made in Michigan, I believe. So this is a 40 panel array, 2 banks of 20. So we'll have 4 purlins. And today they started at the center there and worked their way over. You can see the overlap. There's a couple inches of overlap. They bolt together. here's the other end. So the summary: do your layout, get your holes established per the designs that they provide. Put a string up so you get a nice straight line going from end to end. Plumb the upright beams or columns on the string. Pour them into concrete. Set your elevation. That's where we had that line there. As you go across, using a laser to make sure that we're at the proper height. Once those are set up, install the top girder beams and then the purlins. Put your jacks on and start to build your array. Very excited about this setup and looking forward to seeing what kind of power output we get and the ability to chase the sun as it goes up and down over the horizon over the year, being up higher or down lower, and adjusting the panels to take a more direct hit of the sun in the middle of the day. Hopefully this gives you an idea of what we're doing here as we work on the solar project. Okay guys, so we've got the installation complete, and what I'd like to do is introduce you to Roy Scharf. So Roy is the contractor, is the owner of Scharf Solar,
Yep.
Something like that.
It started as Scharf Energy Systems, and then now it's just become Scharf Solar pretty much.
Right, so as I've explained in some of my other commentary, was looking to add solar to the house several years ago. Didn't really seem to make economic sense, but recently and encountered some folks that had done it and had very good results. And I was actually recommended to contact Roy, and I think you contacted me because you got my cell phone number.
Yep.
And had already been in touch with some other contractors, but he really put forth a compelling case to why I should use him, and I really like the design that he had. So I'm going to introduce Roy here and let him talk a little bit about his business and the system that he specified for our needs here. So welcome, Roy.
All right, thanks for having me.
Yeah, thanks, no problem.
Yeah, my name is Roy Scharf. I started Scharf Energy Systems actually about 10, 12 years ago by now. But back then I got started prototyping small wind turbines for houses.
Right.
And then eventually started doing solar, just kind of played with it on the side at my place and ran things. But and then we started doing it full time. And since then, we've just been running nonstop doing solar installs.
Yeah, pretty bold. You went to college, Embry-Riddle, or where was it, right?
Embry-Riddle Aeronautical University.
Right, so likes airplanes, and then said solar sounds like a good way to make money. Interesting path there, but and so you're located down in Grove City.
Yeah, Grove City area, Western PA.
Yep, so I'm here in northwestern PA. We're in Erie County. So a little bit of a haul for you, probably on a,
It's not too bad.
Not too bad. But why don't you talk a little bit about system design? I was looking for a system that would eliminate my electric bill, and be able to accommodate some potential future growth if we added an electric vehicle. So I provided those inputs to Roy, and why don't you talk about the system that you specified.
All right. The system we have here is 40 panels, and it's using a microinverter system, grid tie only. There's no battery systems. The primary purpose of a grid tie only system is just to save money, essentially. Eliminates or lowers your electric bill. The microinverters are really, really good at that. The panels, these are actually bifacial panels, which means the front of the panel is a normal solar panel, but instead of them just having a laminated back on it, it's another sheet of glass. So it can get ambient light and indirect light from the back, and sometimes direct light depending on the system design and if there's trees, like if they're far enough away, basically. And on this one, it's an adjustable array. The hardware is made by Sinclair Design and Engineering out of Michigan. They make it all up there. They make the steel and everything. And it's adjustable anywhere from about 15 degrees to 60 degrees for the winter. And you can adjust it accordingly depending on what time of the year. And it's pretty simple to adjust. There's no electronics or anything like that to do it. It's manual, but depending how often you do it, like if you do it every couple months or something like that, then there's not a lot of adjustment to do. But basically you just use these jacks and walk down the line. It can take 5 minutes to do it. It's not actually too bad.
So that was kind of a cool feature. I had contractors that really wanted to use that building and put them on the roof, which nothing wrong with that, right?
Yeah.
I mean, it's
roof mounts are generally, depending on the roof design, a roof mount can be cheaper than a ground mount because you're not paying for the extra steel, the concrete, and all that. But in an ideal, like for say this latitude, you'd want it about 35 degrees.
Right.
It's not so much like your latitude tilt. When you run the numbers on a yearly average, in this area we're at about 42, roughly 41, 42. It's about 35 degrees.
Yeah.
Because it favors the summer slightly more, where you get more production anyway.
Okay.
But on this one, since you can adjust it, you have all of it. You can have it perpendicular to the sun at any part of the year.
Yeah.
In the summer, it's roughly what it is right now. It's, I think it was around 18 degrees or so.
Yep.
And it gets direct sunlight. And then in the winter, it'll be tilted to about 60. So the snow comes off really easy, especially we're up near Erie, and the snow belt right up here. So the snow comes off. And you also get more ambient light from the back. And if there's snow on the ground, you're getting light from three sources. You're getting direct from the sun if it's cloudy, or not a cloudy day, but if it's a nice sunny day. You're getting reflection off the front because it's tilted so far, it comes off and hits the front. Okay. And you're also getting ambient and sun or snow reflection from the back. Right. And in this case, it was a nice strategic spot because you got the garage there with the big white doors, which also adds a few percent. Nothing major, but it helps.
Yeah. Yeah, so I was really intrigued by the ground mount design being adjustable. I thought that was cool. I researched Sinclair when you recommended it in your proposal and watched a couple videos. I was like, man, I really like it. And the fact is that it's up off the ground. I can maintain the area underneath it. I can actually, because of where I placed it, I have some more degrees of freedom with getting stuff into my pole barn. And that seems to be, I mean, I'm just really excited about it. Yeah. I could park things out here. It's almost like a little carport.
It sort of is. Yeah, the same company actually does make dedicated carport systems for like large parking lots.
Yeah.
It'd be nice to get into that. That'd be kind of neat. So you can go out to the car and it's in the shade.
Right, right. So kind of simple, really. You mean you've got, 5 upright, beams, and then you've got your girders across, and then
and
you've
Purlins
got
connecting that together.
Purlins.
The panels. Normally your solar panels are held to the racking with clamps between the panels and on the ends.
Yeah.
This one they use since this is a real common panel we use, they set up the direct attachment method.
Okay.
So we bolt them directly to the array.
Yeah.
Saves money, but it's also less hardware getting used.
Right.
So it hooks straight up to there, and then we use zip ties. They send these like plastic channels sometimes you can use, but I'm not a big fan of them. It's just extra stuff and extra plastic. Yep. Zip ties were a lot cleaner.
Yeah.
And it's sometimes the simplest method works best. But like you said, usually when we put these together, they're in someone's yard. Yeah. So there's grass under, and they could either usually they just leave it as grass. Right. Because like as you can see in the summer right now, you can easily get under this with a mower. Right. And you can walk under it. In the winter, you're not mowing the grass, so it doesn't matter. They're closer to the ground. Yep. And it works really nice. We've done a bunch of these, and I like their setup. Ever since like the first time I quoted these, I used to use iron ridge hardware, which was 2 rows of pipes and the rails and all that. But theirs were real close to the ground, which I wasn't a big fan of. And they're also just fixed arrays. But the first time we were quoting this, I was going to quote the guy, the iron ridge stuff and the adjustable, and the price came out because pipe's so expensive. Yeah. The price was within a few $100s, so we just ditched the fixed arrays completely and went straight to these. Well, it was a lot simpler to install. Yeah,
I was going to say the installation seemed like it was fairly straightforward, and we are in concrete. I look on their website. You can hammer these in if you've got rocky ground, I guess, and
a machine big enough to do it. Right, that's a full size skid steer. We just use a little Toro Dingo.
Yeah, which the Dingo is pretty cool, by the way. Yeah. A lot of really handy.
I was thinking there was a point where I wanted to get like a sort of a bobcat style
Yeah.
machine, but then I was like 90% of the time we're in someone's yard and it'll destroy it.
Right.
It'll make a huge mess.
I think you made the right decision, and I'm you know, being an engineer, I am excited to try some experimentation because with these Enphase units, you can look at every panel's output and, you know, white tarp here, silver tarp there, you know, white stone. I've been watching some videos, so I'm really eager to try out some different things. But today's the first day we've actually got any production out of it.
Yeah, we just finished up the wiring and everything today and got it turned on.
So it was kind of cool to pick up the phone and see, you know, hey, there's, you know, 10 kilowatts. So that's pretty cool. So this is pretty straightforward out here. We got the panels, we got the Enphase inverters, and then you come over to a breaker box.
Yep, it's just a pretty standard issue breaker box that acts like a combiner panel. On these, I mean, you don't want to have all the inverters, for example, on a string of wires. It's just too much resistance. So in this, there's 4 strings.
Okay.
10 panels on each string, and the layout here is just like the layout on there. North is here, south is here. This is the 10 panels on the northwest side, and so on.
Yeah.
But this basically just backfeeds the breakers and combines that to a single output up here, which then goes down to the house.
Right. So we'll take a walk over and go into the house and show you what's down in the basement. It's really not intrusive.
Yeah, what's in the basement is just the little control computer and
right.
current transformers to measure output.
And then out front, we've got a disconnect there for my utility provider and all that good stuff. But no batteries, so that's not this isn't a battery system, as Roy said. It is a system that is truly grid tied and is meant to reduce my electric bill. So we're pretty pumped. Let's go take a walk inside.
All right, so what we got here is basically, this was your existing internet hardware, and this was a nice place to put it. The connection is actually in the transfer switch. And there we go. And I've seen at least one installer screw this up badly. But anytime you got a transfer switch, you don't want the solar, for example, if it's a grid tie only system, in the same circuit as the house or the generator. Because what will happen is, if the power goes out and the generator comes on and feeds the house, and the solar will think the power's back on and try to feed the house. And I don't remember exactly what will happen. It'll either overvolt everything instantly and just turn off, or it fries everything in the house.
We don't want to fry.
So anytime you got a transfer switch with a grid tie only system, you connect it to the line side of the transfer switch. And I just left a bunch of extra wire in here just in case this ever gets changed out. But the wire coming from outside goes through there and then out to the disconnect, and then it comes back down into here, and then it's the line side connection, and that's it. But this over here is the computer that controls the entire system. That'll show you the internet connection, the monitoring, and it has the sensor wires that go in here just to measure the power coming from the panels and the power on grid side. And what that does is, the difference is the house's usage, basically. So it can give you both things.
Which is really awesome. And I think Enphase has done a great job of essentially providing, you know, amateurs, people that have no real knowledge of electricity. You can sit there and look at this really cool app and be like, oh, we're making power and it's going back into the grid, or hey, we're consuming, someone go turn off the, you know, the coffee pot, because you know, you start to become a little bit like, I just want to make energy.
You notice it more,
you pay attention. So
it's kind of like, I guess there was a saying where, like when cars first started getting the little gas mileage gauge in there, and people started getting better gas mileage, the gauge didn't do anything, but it made you kind of notice it more. So you paid attention to it.
Yeah, absolutely. So let's take a walk out front and we'll take a look at what's out there next to my meter. Okay, so out front here we got our meter, which hasn't been changed out yet. And
it's still the original.
And that's, so the utility provider comes out and does an inspection, and then they will pull the meter and put one, then it'll go backwards, right? It'll spin backwards.
Yeah, they'll put it in a two-way meter.
Yep.
And this is basically just the disconnect for the whole system. It's pretty generic, and it's just required for utility.
Yep.
Because what will happen is, like, they still require this, but what happens is if the power goes out, a grid tie only system shuts down. It's, as odd as it might sound, it's powered by the grid.
Yeah.
And then reverses the current flow rate just by changing the voltage slightly. But once you lose power, because there's a feature called anti-islanding. Like if somebody's working on the lines, you don't want it running.
Right.
And that's pretty much it. This is
so safety protocols here.
Yep.
Right. Excellent. Well, very good. So again, fairly straightforward, you know, installation, and nice and clean, looks good, and it works. So we're pretty excited about that. Okay, so that's an explanation of the system, and you heard it from the horse's mouth, the guy who is the expert. He's a savant with electricity and waveform and all that kind of stuff. I was very fortunate to meet him, and I think his crew did a great job installing this. It's a very clean install, and I'm excited to get 20 plus years, 25, 30 years of life out of this. And based on the numbers, it's pretty substantial what the impact will be to me and my family. So I think it's a good investment. And I look forward to giving some updates over time. And,
sounds good.
And I do appreciate you, recommend you. And you can see if you have a need for some solar, reach out to Roy here. We'll put a tag here in the comments down below and in the description. So thanks a lot.